I want to discuss locating holes in rational functions. It was mentioned in a previous video, but I didn't get to elaborate on it a bunch. Holes occur at domain values that cause division of 0 by 0. In the example given here, I'm going to get a hole at x equals -2, because when I factor what was given, I get a common factor of x plus 2 that can be divided out. However, even though it simplifies to this rational expression, this isn't identical to the one given, and if you consider x equals -2 in the original function, you would get 0 divided by 0. So a hole occurs at x equals -2. Now, to figure out the y value where this happens, substitute -2 into the simplified rational expression. So put -2 minus 2 into the x value, or -2 rather, into the x value of the simplified rational expression, obtain -4 over 1, or -4. So we find that the hole is at -2, comma -4. Now, your graphing calculator is going to do strange things sometimes. Let's have a look at it, and I want to show you what you get. Here's the function, and you may choose zoom 6, plus or minus 10 window as a common choice. Observe that at x equals -2, there doesn't seem to be anything wrong. No hole, nothing missing. If I were to trace the function using the trace button and try to go back to x equals -2, you'll see that I get these strange decimal values and it skips right over -2, not making it very clear at all. If I choose calculate value and type in -2, y is blank, which is the calculator's way of saying it's undefined. Now, zoom 4 is a better window for showing things clearly without being misleading. However, in this case, when x is -2, you'll see that the graph isn't being represented, as well as another branch not being represented. So what we're going to need to do is zoom out. First, go to zoom, and we want to choose the memory option and set factors. Oops. Memory option. Set factors, option 4. Make sure your factors are set to 2. They're factory set at 4. Once you've done that, choose zoom out, which is option 3. The cursor will flash at the origin, which is the reference point. Push enter. The zoom will zoom out, allowing us to observe the value when x equals -2. Again, if I chose calculate value, substituted -2, I will see that y is undefined there. I'm just going to do a screen capture of that and embed that into our notes here. So my hole is showing up right here at -2, comma -4. It's really important that you choose a window that allows you to observe the hole, and your calculator will often be misleading about that. Zoom 4 is a good choice. Now I want to talk about intercepts. You probably know this, but it's worth reviewing that y-intercepts happen when x is 0. X-intercepts happen when y is 0. All we need to do to find a y-intercept of a rational function is substitute 0 for x. That's like canceling all the terms in x. So my y-intercept is going to be at -4 over 6, or the point 0, comma, -2/3. And if you look at the graph up here, that's supported graphically. The x-intercept's a bit more work. It's when y equals 0. So I need to solve this equation. Now consider the right side as a fraction. Fractions equal 0 when the numerator is 0. But this is misleading. Remember that I had a common factor. I actually want to not use the original rational expression, but use the simplified one right here, -2 x plus 3. So it leads to 0 equals x minus 2 and x equals 2, or 2 comma 0, again supported graphically. Look here at 2 comma 0, there's my x-intercept. There's my y-intercept. There is no x-intercept over here because that was a hole. That's the basics of how to do x and y-intercepts and about holes.